Hey guys, so after finding a missing side using trig in right triangles and then a day of practice, we're going to move on to finding missing angles, right? So using your calculator, I'm going to skip the do now of finding the missing sides, right? However, I am going to write up here, as we always need it, in right triangle trig, SOHCAHTOA. So, using your calculator, find the value to the nearest hundredth, right, that's 2 decimal points, of cosine of 54 degrees. So what we're saying is when you take the cosine of 54 degrees, what is the ratio equivalent to? And you get 0.587, which is 0.59. Okay? Now the question is this: what if you knew the ratio between the adjacent and the hypotenuse side was 0.59? Then could you find the degree? And yeah, that's what we're going to do today, finding missing angles. So it says here, if the tan of some angle x is 0.8412, what is the angle x to the nearest degree? So the way we do that is called inverse. You may remember tan inverse of 0.8412, right? Now, how do we do that? Well, what we need to do is, in our calculator, we're going to hit f of x, and instead of hitting tan, we're going to hit tan inverse. It's right underneath it. And then we're going to put 0.8412, and it's telling us that if the angle is 40 degrees, then that will be the ratio. Okay? Now here, sine of x equals 9 over 12. So think of a right triangle. All right? And we know sine is opposite over hypotenuse. So if we take an angle here, and the opposite side is 9, and the hypotenuse is 12, then there is a way we can find out what this angle is. What is this angle that makes an opposite side of 9 and a hypotenuse of 12? So let's do inverse sine of 9 over 12. And that's saying that this angle must be, rounded to the nearest angle, 49 degrees, as you can see right here. Okay, so what are our steps here for solving for a missing angle? Let's fill in these steps, and then we'll do a couple of practice problems with it. Okay, so step one, sorry, my iPad is being weird. Step one, identify all sides of the triangle, just like we did before, in terms of theta. So here we have thetas right here, so let's label the sides. 3 is opposite, AC is the hypotenuse, and the side touching theta is the adjacent angle. Step 2, determine the correct trig ratio. Okay, so in this problem here, the sides that we're working with are opposite and adjacent. So what is the correct trig ratio for opposite and adjacent? Tan. Okay, so in this problem, tan is the correct ratio, so tan. Step 3, substitute values. And then step 4, use inverse trig. So tan of inverse of opposite over adjacent. We're going to put this into the calculator. Inverse tan of 3 over 4, enter, and you get 36.9 degrees. That means this angle here is 36.9 degrees. All right, so let's do some practice, and then I'll let you guys finish the bottom, okay? So find to the nearest degree theta. So here's theta. Now, first step, label the sides. 5 is opposite, 7 is hypotenuse. Step 2, determine the correct trig ratio. Opposite, hypotenuse, sine. So sine inverse, since I'm looking for the angle, of 5 over 7. Enter it into the calculator. It says to the nearest degree, you will get 46 degrees. Let's do one more together. So here's theta. We got to label the sides, right? Opposite the right angle, so 10 is the hypotenuse. And then it's the side touching theta, so this is adjacent. So which side uses hypotenuse and adjacent? Let's see. Cosine. So cos of theta equals adjacent over hypotenuse. So now, inverse cos of 5 over 10, put that in the calculator. Inverse cos 5 over 10, 60 degrees. So theta equals 60 degrees. Let's also talk about one other thing. What is this angle down here going to be? Let's call it x. Well, 90 and 60, and this is, add those together, subtract from 180, you'll find out that this is 30 degrees. Good. So finish the rest, and I'll post a key later on. Any questions, just don't forget, email me, remind, whatever you got. Have a good day.